b power, that is just x to the a minus b power. And this is the division rule. Oops. This is the division rule. Okay? If you have same variable to different powers, you can simplify that by subtracting. So the key word here is, if you start with multiplication, right, it turns into addition. If you start with division, right, here this bar means division, then you're going to subtract. Okay, so those are the two big rules so far. Now there's one more main one, and this one's called the power rule. So I know this seems kind of weird because you're like, wait a minute, don't all these problems have powers? And that is true. They all do have exponents or powers in them. But this specific one is when you have, for example, something like this. X to the fourth power to the third power. So you have kind of like double powers, or it's like a power to another power. So you're pretty much going to look for something that looks like this, where you see maybe something, where you see something maybe protected in parentheses, and then you see another power at the top. So let's think about this. If we think about what a power means in general, right? So if we think like, oh, x to the, 6th power, that just means 6 copies of x, right? So how did I know how many to make? The exponent told me how many to make. So in this case, we're thinking very similarly. We're saying, okay, I could read this as 3 copies of x to the 4th. So if I do that, then I could write this as x to the 4th, x to the 4th, x to the 4th. Oops, sorry, that 4 wasn't that good. X to the 4th. Okay, so notice that I made 3 copies of it because my power was 3. So that gave me 1, 2, 3 copies. Now, if I think about this as, if I do the exact same thing and I think, what does it mean to have a power of 4, I could also write this like this. So that would be, the first one would be x times x times x times x. The second one would be x times x times x times x. And the third one would be x times x times x times x. So again, very involved process, looking at and analyzing each power separately. But this is pretty much the longest way of saying this, what we started with. So let's see if I can write this in a slightly simpler way. Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I ended up with 12 total copies of x. And I could write that more simply as x to the 12th power. Okay, so x to the 4th to the 3rd is x to the 12th power. So again, if we had something crazy like x to the 17th to the 12th, right? You don't want to spend all that time writing out, this many copies of this many copies of this many copies of this. So is there a shortcut? Yes, there is. And I'm going to ask you to pay attention to the 4, the 3, and we ended up with 12, right? So how could 4 and 3, so 4, what could you do to, actually I should write it like this. What could you do to 4 and 3 to get 12? And so you're thinking in your toolkit and you're like, okay, could I add? Could I subtract? Could I multiply? Could I divide? And you are going to hopefully find that you could either multiply. If you, I know some of you like to use x. I mean, that's how we first learned to multiply with an x. I'm gonna put a little dot. Okay, so we're seeing here that the trick is to multiply the powers together. So let me write it formally. If you have if you have x to the a power, so that's, let's say we start with some power, and then you have an additional power on the outside, right? X to the a, and all of that to the b, then the shortcut would be you have x to the a times b. Okay? And this is your power rule. When you have power to another power, you're going to go ahead and multiply the two together. Okay, so we have seen multiply. So we have seen 3 rules: multiplication, addition becomes addition, division becomes subtraction, and having a power to another power or double powers results in multiplication. Okay, so again, just quick summary. Good morning, everybody. This is a small extension video to the one on reviewing the exponent rules. I just wanted to do a couple of examples with you to show you how to use them. So I wrote all 3 rules here to save some time. Those can be seen in the previous video. So multiplication, division, and power, and I want to just take a couple minutes to go over some of them. So in this first example, I'm hoping that you're able to pick up on the fact that there's multiplication in the middle. That dot typically means multiplication. So that's a big clue that at some point you're going to have to add exponents together. And hopefully you remember that when we don't see an exponent, the assumed power is 1. So the way that I would approach these problems is I would split it up into, there's usually numbers involved, so the 7 and the 5, and then there's usually a property involved. So the reason I split these up is because I want you to treat the numbers in their own way, and then I want you to treat the powers in their own way. And I think that's going to help because now you can easily do 7 times 5, so you'll get 35. And then this is where you will apply the property. So m to the 5th times m to the 1st. Well, the property says we should add the powers. So what is 5 plus 1? That would be m to the 6th power. So that would be the answer to the first one, 35m to the 6th power. If we look at number 2, we can see that it has the same structure as this one right here. It has like power to another power. So again, I would treat this kind of 2 ways. I would recognize on the inside that there's a there's a 3. And then there's a b to the 4th. So this is important because remember, when you're expanding, the b also gets copied. So this is 4, right? 4th power means 4 copies of it. So I want you to notice that I want you to notice that not only does the b get the power, but the 3 also gets the power. So if you wanted to do a shortcut version of this, you could give this the power and give this the power. So I would write this as 3 to the 4th power times b to the 4th power. So 3 to the 4th power we can do very easily. You can either grab a calculator or you can multiply it out. So 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So that would be the yellow part. And then if we want to do the second part, that would be b to the fourth to the fourth. And if you notice, the power rule says we should multiply the two powers together. So if we have a 4 and another 4, right, multiply together. So this would be 81b to the 4 times 4, which is 81b to the 16. So there's that one. Number 3 is a division, and again I would treat the numbers separately from the letters. I think that's going to help. So if we kind of split it right down the middle, this would be 4 over 2, and then this would be m to the fourth over m to the negative 3. So 4 over 2, that's pretty straightforward. That's going to give us 2. And then this one, we have to look at our rules. So that's clearly a division rule. And the division rule says subtract the powers. So let's go here. If we look at our powers, they are 4 and minus 3. This is a very special case where you have to be very careful. So if we do this, we would get m to the 4 minus, so notice I introduced a minus, and notice there was a minus that was already there. So we actually end up with double negatives, or two negatives touching, which create a positive. So this ends up being m to the 4 plus 3, which is m to the 7th. So the final answer would be 2 from here, this 2, m to the 7th power. We also get some that start looking a little crazy, but if you just apply the properties, shouldn't be too bad. We see one that is power to a power. So here's power to a power. So what is the rule? Multiply these powers together. So 5 times 5 is 25. So this would be x to the 25th power. And then this one, same thing. We have power to a power, but also notice that there's a 2 stuck in there. So the 2 also gets the power. So this should be 2 to the 5th times x to the 6th to the 5th. So just notice how I gave each piece of that its power. This one can easily be simplified to 32. This one, again, we would multiply the power, so that would be x to the 6 times 5, which is 30. So then this is where we're at. We have x to the 25 times 32 times x to the 30th. And then now you'll notice that we have a multiplication rule involved. So when multiplication's involved, what do we do to the powers? We add. So then our final answer would be 32x to the 25 plus 30, which is 55. So I'm hoping that you're just seeing how a lot of these powers get repeated. Right here with number 5, we have a numerator and a denominator. So what I'm going to focus your attention on first is up here at the top. Notice that if I kind of ignore the bottom, I have a multiplication rule. So the multiplication rule, I can do the 2 and the 2 very easily. So 2 times 2. And then there's x to the 4th times x squared. So this, pretty straightforward, that's 4. This, when I have multiplication, I should add the powers, so that's x to the 6th. Now I can bring back the bottom. And once I do that, I see there's another property, the division property. So I'm going to treat these as their own thing, and I'm going to treat these as their own thing. So 4 divided by 2 is 2, and then x to the 6th divided by x to the 4th. The division rule says we should subtract the power, so that's x to the 6th minus 4, or x squared. So then your answer is going to be 2x squared. And